We are live now. Estamos ao vivo. Olá, developers. Or should I say hello, developers? Good night for those who see us live. Good morning and good afternoon for those who see this recording. My name is João Lucas Farias and I am your host now. And today we have a special guest called Anthony. Say hello for everyone, Anthony.
Olá, Brasil.
That's very good. As I said to you, your Portuguese is very better. It's better than my English.
Thank you.
Okay. So, just some announcement after we start. Everybody, please thumbs up, subscribe, and share with your friends. Continue follow us in the social medias and enjoy this content because Anthony is actually writing a book about this subject. So he is a specialist in this subject and he can answer everything that you should question him. So let's just start, Anthony. Are you ready?
I'm ready.
Okay, so let's rock. The power is yours.
Hello, everyone. In this session, I will introduce you gRPC with ESP.NET Core. First, if you want to follow me, you can check my blog right here, my Twitter account, my LinkedIn account. You can as well check my GitHub repos if you want some code samples. And I have some NuGet packages. You can find me on nuget.org. So in this session, I will introduce gRPC fundamentals. So gRPC with no special framework. What is gRPC in general? gRPC works with HTTP2, and I will give you some words on HTTP2, and then I will introduce you a gRPC in ESP.NET Core. Then I will introduce you gRPC Web. What is gRPC Web? What's the difference between gRPC and gRPC Web? And I will show you how it works with ESP.NET Core. Then I will give you some words on gRPC and gRPC Web in Azure. Then we will compare gRPC and REST and why we should use or not gRPC with .NET. And then I will give you a little demo. Let's go. So what's gRPC? gRPC is a RPC framework, so a remote procedure call framework designed and open sourced by Google. It has been designed in 2014. And gRPC is very, very, very special. It's working only with HTTP2 and TLS, so HTTP2S. So it doesn't work in HTTP. It doesn't work with HTTP1. So HTTP2S is mandatory. How does it work? Serialization is made in binary. And there is a language that provides developers to design the serialization with a language named protocol buffers. And I will show you an example after. Protocol buffer is like WSDL with WCF. It's a contract-based. gRPC is not compatible with browser for many reasons. Some browsers, many, doesn't support HTTP2, and browsers doesn't support binary data. That's why. And regarding Microsoft Azure, it's not supported by Azure App Services. Why? Because HTTP2 and IIS. IIS doesn't support HTTP2. But there are some workarounds I will show you a bit later. how does gRPC work? It's a gRPC framework which send a request over HTTP, like I said. And gRPC uses post verb only, and URLs are auto-generated, so you don't have to manage HTTP verbs or URL. It's self-generated. Content type is application gRPC or application gRPC plus proto. It works with classical header like any HTTP request. Okay, you have headers, content type, and many kind of headers. And gRPC has as well its own headers named trailers. Trailers are custom metadata, custom headers delegated to gRPC. Regarding answer, it's a bit weird at the first approach, but whatever happens, it's always a HTTP OK 200 response. So it's a post in the request, and the response is always
Hey, Anthony. I don't know why, but I think your mic is muted. Not yet. We cannot hear you.
Hello? For real? It's muted? I don't know what to do. I don't know what to say. It works on my hand. Huh? Yeah, it works for me. I tested myself, and can you hear me? Hello?
Hello, Anthony.
Can you hear me?
Okay, now we can hear you.
But
We don't know what happened.
I did not touch anything. So
Okay, it's technology, you know it. It's have your own feelings, and when it feels sorry for something, we have to pay the price. So
okay.
it's okay. You can come back in a few slides, please.
Where?
Some more, some more. Yeah, that one.
Okay.
The next one. Yeah.
So you can hear me here, but in YouTube people doesn't hear?
Now we all can hear you.
Okay, very weird.
So you
Okay.
can proceed now.
Okay. I restart again. So okay, so let's go back. So gRPC works with post verb only with URL auto-generated. Content type is application gRPC and application gRPC plus proto. It works as any HTTP request as well. It works with classical headers. And gRPC has a specific headers named trailers. In trailers, we can send many custom metadata. The responses are always sending HTTP status 200. So the real answer to response to rely on is the gRPC status 1 to 16. So I can show you a bit later how what category are. And finally, binary requests and responses. I mean that all requests from client to server and responsive from server to client are sent in binary. If you want to learn more about gRPC in HTTP2, you can follow this link. Okay, so how gRPC works? It provides unary calls. What are unary calls? It's like a web API. So you have a request and you have a response and the connection clauses. So the client initiates a call over HTTP asking a precise method name and send request message and metadata, trailers, we said. The server answer a response with the gRPC status and metadata, trailers as well. But it's not only that. gRPC handles, supports server streaming calls. So a client can send a request and the server can respond many response messages. It's always more performant than a big amount of data over the network. It's more performant to send data streamed in that way. And the last response is the gRPC status and metadata sent by the server. Client streaming calls are supported. It's the same thing. The client initiates a request to the server with the method name and metadata and send multiple messages over the same connection. And it's more performant than a big amount of data over the network. And at the end, the server responds with a response message, a status, and metadata. And finally, gRPC support bi-directional streaming. So the client always initiate the connection with a metadata, and the server can respond at any time. It's up to you, up to the developer. The client can send all request message, and when it's done, you can tell the server, I sent all my request messages, and the server can start to respond, or you can respond asynchronously. It's up to you. gRPC support deadline and cancellation. What is a deadline? It's a timeout in the gRPC world. So if I set a deadline of 5 seconds, then the gRPC request will be canceled after 5 seconds if it's not completed. And a cancellation is fired with a cancellation token, for example, in the ASP.NET Core framework. The cancellation is propagated to underlying job if it's managed. So you can cancel everything if you manage it. Trailers. So as I said, trailers has custom metadata, and it's very special with gRPC. I'm back. Then the response is not the same. The first packet to be sent in the response is the classical HTTP headers, then data, and then trailers. Trailers are always sent at the end of the request. So if you have a crash during a streaming call, you might have some data messages, classical headers, but you will be able to get trailers by handling the exception, for example. So they are not sent at the same time. I will show you a code sample. gRPC status. So in trailers, we can find the header name gRPC status. OK is 0. So if everything went well, you will receive a number 0, this gRPC status to 0. Depending on the framework, you will receive the number or the code. In ASP.NET Core, you have both. Cancel is 1, for example. Deadline exceed, like timeout, it's 4. Not found, it's 5. And we have, you can see, you can find the same codes than HTTP1. 13 means internal, for example, and if you are not authenticated, it's 16, like RESTful APIs 401. How does work HTTP2? Okay, so this is the key of the gRPC performance. gRPC uses binary serialization, but this performance is made by HTTP2 essentially. HTTP2 allows multiplexing, so multiple HTTP requests on the same connection. In the case of streaming, as you can see, in the same HTTP connection, you can send multiple requests for example. So it's very powerful, and you don't need to initiate a new connection each time you want to send an HTTP request. HTTP2 allows binary transport, and compression on binary is very efficient. So binary is more performant, but there is a compression that is very efficient on binary data. So good performance here. Flow control. The data flow can be controlled to optimize server resources. What does it mean? It means that the server can manage requests on a certain order if the client manage it. So if a client say this request is more important than the other one, the server can handle requests in a different order, and it optimizes server resources. And the fourth feature of HTTP2, which is not supported by gPC, is the server push. What do we need to use gRPC in ASP.NET Core? Visual Studio 2019 minimum and ASP.NET Core 3.0 minimum. So it's compatible with ASP.NET Core 3.0, 3.1, ASP.NET Core 5, and more. Maybe very soon 6. What you need to do is to use a gRPC template that you can find here by typing gRPC. As I said, you need to create a protobuf file, which is a description of your service. So how to add the protobuf file? You go to ASP.NET Core General and you select protocol buffer file. How does it look? Headers. So you need to choose Proto2. Proto3 is a me now. It's okay? Can you come in the show, please, in the live? Can you come in the live, please? Connect, please, come. Hello, hello, can somebody hear me?
Okay, now we can hear you. Actually, we stopped. We could not hear you when you were talking about the Proto T in the code.
Here?
Yeah, that one.
I don't know what's happening.
Neither do I.
Okay. So,
But going, the
okay.
subject is interesting.
Okay. So let's back again to protobuf file. So how do we define services? First, with the syntax. There are three syntax: Proto 1, Proto 2, Proto 3. Proto 2 is deprecated. Proto 2 is still in use, but doesn't have Proto 3 feature. So Proto 3 is recommended. Package, I will show it to you a bit later, but it's a way to version your service. So if you want to have several versions of the same service, you can call it V1, V2, V3, V4, etc., etc. To define a gRPC service, you need to use the service keyword with RPC returns, which defines the response, and the method name, the RPC method name, and the request. Here, the message is empty request. Why? Because protobuf protocol buffers a syntax requires always a parameter. So if you don't have any parameter, you have to define an empty message. That's mandatory. Or you can define empty message, which is built in. So you can build your own or use empty. Then you can define all your message here. Any type, string, int. Repeated is a collection, so there is no notion of array, list, collection. It's repeated. Repeated is a sequence of the same parameter. So in array, but it's not an array. You can use enums. And number here mean that in the serialization and deserialization process mean that what is the name position in the serialization. So to serialize and deserialize, we need to know the position of each parameters. And you can use enum here with the same syntax, 1, 0, etc., like C#. How gRPC services are generated? So once you define your protocol buffer file, you just need to compile with Visual Studio, and behind the scene, it will use a tool named protocol buffer compiler. And in obj debug, for example, .NET Core app 3.1, it will generate the first one. My own service contains messages, and the second one will generate the RPC methods. And once you have compiled it, you can write your service. You just need to inherit from your service. This is the syntax. And you can override your method. So you need to override them because protocol buffer, when they are compiled, they generate a virtual method, a gRPC function, which is intending to be overridden. Because if you don't do that, there is a virtual method that send throw not implemented. So something is generated by default. I don't show it here, but I will show you in a later demo. It's compatible with injection dependency like ASP.NET Core MVC, Blazor, or whatever. As you can see here, the proto file is stored by default in a proto folder. How to configure gPC service? By default, if you use gPC template, it enables gPC by default. I'm back. I need to restart my my micro. So it's okay. That's weird. I don't know. It's the sound is cutting every 5 minutes. I don't know why. Fine. Okay.
It is just because it's live and you are very good and your machine is jealous about you.
I don't know what's happening. So I mute and remute after 5 minutes. And yeah, just tell me, just send me a message and I restart my my microphone. Maybe there is a bug somewhere. It should not. It should not stop like this.
Okay, that's happened. Just keep going, guy.
Yeah, but it will happen a lot of time again. So just tell me and I will reset my my microphone.
Okay,
Sorry.
okay.
So if we want to create a client, just open service references in your project and click on add new gRPC reference. So what you need to do is to find on your disk anywhere on in your app. It's better in your ASP.NET Core solution to store your proto. You add it, and then you compile again. This is the same operation for the client, and messages will be generated, and the client will be generated. So the first file is similar as the file server, the message file server on the server, but the second file is very different. This one is the client, but for the server, there is no client. So there is some differences on the second file. How to create a gRPC client with any .NET client. any framework. So you just need to use gRPC.NET Client NuGet package, and it's very generic. It allows you to consume any gRPC server app with a gRPC channel, we say. It's very generic, so it can work in any framework. So you need to create a channel. You need to define the URL, and the channel is a connection to the gRPC server. And then you need to pass the channel in parameters to your client, which is auto-generated as well. And then you provide your call. So like I said, request messages will be generated, and you just need, if you don't need any parameter, to use your well-defined empty request. So it's a custom empty message, but you can use as well new empty, which is native to protocol buffers. If you have any exception, you need to handle it with RPC exception. And inside, you will be able to get error message, but as well trailers. You can find trailers within the exception here. So this is the generic part. You can use, if you are using a .NET Core app or .NET Core 3.1, .NET 5, and more, like .NET 6, you can use here the client factory, gPC.NET Client Factory. So you can use it in a console app. You can use it in ASP.NET Core app like MVC, Blazor, Razor, etc., etc. And it's a bit different because it uses injection dependency injection. And you can consume your data like this. If there is an exception, you need to handle a RPC exception, and you will find again your trailers inside. What can we do with gRPC? With gRPC, we can perform authentication, for example, a GWT. But you have to know that Windows authentication is not supported because Windows authentication does not support HTTP2. You can perform any CRUD operation as you wish, no problem. You can perform logging. You can perform audit and monitoring with Application Insight. But you might encounter an issue with Application Insight because when there is an error, if you remember well, if there is an error, gRPC will return HTTP status 200 OK. So you will have to click on Application Insight to find errors. You will, in the default list on Application Insight on your Azure portal, you will always see HTTP 200 OK. So you need to find by yourself any exception. You need to go to the HTTP request details. We can perform back again. I think you can hear me now. So I just needed to restart my connection again.
Okay, now we can hear you very well. So go ahead.
Okay, thank you. And we can use integration test with test server. So test server, like any ASP.NET Core app, it's compatible with gRPC. But there is no native validation like data annotation, required attribute, etc., etc. So you can use my package here that is based on Fluent validation and provide message validation. So you can download it on NuGet. So everything here, it's a bit too much for today. I will show you more in detail all that features or to define them in another session. Let's go now to gPC Web. So gPC Web, it's a gRPC, it's gRPC, but it's a bit different. Why? gPC Web is a gRPC version compatible with browser. Wow. So how does it work? A long time ago, in 2016, Google and Improbable, two companies, were working on a JavaScript library in order to consume gRPC service. But this library needed a modification from the server. So a gRPC app, as I said, is not compatible with a browser because messages are serialized in binary. So servers needed to be adapted to send text instead of binary data. And in the meantime, support gRPC1, HTTP1 and or HTTP2. So this is a new content type named application gPC Web or gPC Web text. To adapt the server, it's not the reality. In fact, the server remains a gPC app with HTTP2 and binary responsive. In fact, you need to implement a proxy between the browser, the final user, and the gPC server. A proxy like Envoy, which converts binary serialization, binary message from HTTP2 to HTTP1 or 2 and in text. So the consequence is your proxy needs to be aware about your protobuf. It needs to know your protobuf definition, else it can't work. So gPC Web JavaScript library went compatible with gPC because it consumed with most of time HTTP1 text instead of binary message. The great thing with gPC Web in ASP.NET Core, oh, I forgot. How does gPC Web JavaScript library work? You need to download the protobuf compiler and generate in TypeScript and not in C# this time your protocol buffer. So your client needs to know your protobuf files, and once protoc is running, it will generate services and messages. So it generates everything in JavaScript, and there is a plugin for TypeScript. What does the TypeScript plugin does? It just create TypeScript definition. You can see .d.ts for both services and client. How does it look like? It is a component, Angular component, and how I can perform a unary call. For your information, gPC Web is only compatible with server streaming and unary. So this is the TypeScript part. Now, the beauty of ASP.NET Core is the fact that the whole application can be converted to a gRPC web app. So what's the beauty of this? You don't need anymore a proxy. So your ASP.NET Core application is able to send data in HTTP1 and text, and not only in HTTP2 in binary. So if you are converting your gRPC app to a gRPC web app, what you have to know is gRPC in HTTP2 and binary message will still working. It just bring the text message with HTTP1 feature. So you can still use the same service with binary HTTP2 or text and HTTP1. This is very awesome. What you need to do is to import in your ASP.NET Core app gRPC ASP.NET Core .web. What you have to do, very important, because you are talking to a browser, you need to configure CORS and add these headers, accept gRPC status and gRPC message. And then it works like a web API. What you need to do then, just enable use core, use the middleware, use gRPC web, and define a service with its policy, CORS policy, and gRPC web enabled. What does it mean? It means the first service, my own gRPC service, work only with HTTP2 and binary. The second one, country gRPC service, work in binary HTTP2 and work with gRPC web with text and HTTP1. That's awesome. gRPC web for a .NET Core client. So it's again different for a client. What you need to import is to import gRPC.NET client.web in your client. And it's a bit more complicated. You need to instantiate in gRPC web handler. Why we need to do that? Because you need to set up the gRPC web text feature. So you create a channel in the same time, but you have a handler that tells to the server, I want gRPC web and not gRPC. That's it. And you consume your data as you should have to do with gRPC. Any exception, gRPC exception, it works as the same. So remember gRPC.NET Client Web package. Now, if we talk about a bit Microsoft Azure, what you need to do to know first and do after, I will explain you. If you want to use gRPC in IP service, you can't, because HTTP 6 and HTTP2 don't like each other. So HTTP 6 is the web server, the IIS of Azure App Services. It doesn't support HTTP2. So if you want to host a gRPC app in Azure, you can use Azure Container Instance, but it's partially supported. Why? By default, Azure Container Instance provides you dynamic URL. So each time you restart your container in SCI, IP address will change. So you need an app gateway to be able to configure a static IP. But app gateway is not compatible fully with HTTP. Can you hear me now? Okay.
Yes, I can. You go ahead.
So what you can do instead of SCI, you can use Docker. So you can use container on VMs, virtual machine, Windows or Linux. You can self-host on Kestrel on your VM, and you can host on Kubernetes. It works like a charm, but it's a bit complicated. If you want to use gRPC Web, you don't have any restriction. It's fully compatible with all Azure services. That's it for Azure. gRPC versus REST. What are the difference? As you can see, status codes are different. So HTTP REST request handles and rely on HTTP code status. gRPC relies on gRPC status that are stored in trailers, and trailers are headers. So it's a bit different. Binary versus JSON. So binary is not human readable versus JSON, which is human readable. So there is a difference. It's hard for debugging. If you want to debug, you need as well to use a proxy which convert binary to text, and you will be able to convert to a readable data for debugging. First one works only with HTTP2 and Web API, for example, REST, etc. is compatible with HTTP1 and HTTP2. HTTP2 for REST is enabled in ASP.NET Core since ASP.NET Core 2.2. gRPC needs code generation like WCF versus REST, which doesn't need any code generation. And the main difference for sure is a browser support. But in fact, you can use gRPC with gRPC Web for ASP.NET Core or using a proxy envoy, not practical. Why should you use gRPC or not? On my hand, I would use it for performance, HTTP2 and binary. The mix of binary data compression and HTTP2 feature like streaming make it very powerful. It's convenient because you have bidirectional and streaming, client to server, server to client, and both. Very practical. gRPC is strict. So the URI format is not designed by developers, not verbs. So it's only the same URL which is generated by the client. And it's always post 200. So there is no debate, or should I use that kind of route, or it's done. There is no debate. You don't need to manage it like Web API, for example. Code generation versus no code generation. Yeah, for some people, it could be boring to use code generation. It's not fully supported by cloud providers. It's not only Azure, but many providers are not compatible with HTTP2 for some of the service. And with those authentication, Kerberos is not supported neither. So it could be blocking for some kind of application if you cannot perform Windows authentication. gRPC Web is compatible with Windows authentication, so good to know. I'm restarting my connection before it closes again. So it's time to provide you a demo. Let's go for the demo. Okay. So this is my server app country service web, okay? I'm using gRPC ASP.NET Core. I want to explain you this. It will be part of the second session. So I can use different proto, and I separate them in different folder, V1, V2. What does it look like? Don't worry, it's my Visual Studio. So syntax proto free package gRPC V1. As I said, it's used for versioning. And optionally, I can define a C# namespace option. Once my service will be generated, it will be generated in this namespace. So I can use two versions of the API in two different namespaces. So it's great. Let's go back to V1. I define many services. As I said, you can use the native empty message. Up to you. If you want to declare a server stream application, you just need to set the keyword stream. You see, here, if I remove it, it's a unary call. If I add it here on the response, it's a server streaming. If I want to create a client streaming, I need to add stream on the input parameter. Once again, if I remove it, it's a unary call. And if I want to define a bidirectional service, stream and in the request and stream in the response. My messages. Okay, you can use anything. As I said, int, bytes, strings. And if you use date, you need to use the native that time of protobuf, because there is no equivalent for .NET, and behind the scenes there is a wrapper that transforms the timestamp to a .NET type with protoc. So it's like this. If you want to import that type, you need to import it. It's already known by protoc, so you don't need to have a file anywhere on your app. This is native. You just need to import it like this, and the missing file will be found automatically by the protobuf compiler. Same for empty. This is a native type. You need to import it. Okay, so let's see my service here, country gRPC service. So I'm inheriting from this one, my V1 version. I can use injection dependency, no problem, a service, calling a service. If I want to define a server streaming, I need to add the parameters here. iServer stream writer with the defined type to be sent to the client. Since I'm getting data from the server, I can start to stream data to the client. So there are many kinds of implementation. You can do a lot of things, but what I like to get is getting all data from the server and streaming them one by one to the client. Once I'm done with all my data, I need to complete the task because it's async by default. So I have my empty request. I'm not using it. Server call context is the HTTP request, the HTTP context of gRPC. And so server call context is the gRPC HTTP context, and you can extract from it the HTTP context and get headers. You can get even trailers. So once you're done with the streaming, you complete the task. If in case of a unary call, it's that simple, it's like a web API, you return data as is. If you stream from the client, it's different. You are not using a stream writer. Stream writer is to stream from server to the client. And now stream reader is reading stream data from the client to the server. So on my case, you can, for example, like here, manage data each time you receive it, but on my end, I prefer to avoid exceptions, getting all data first and performing operation to the database. Because if it breaks on the middle of the request, you will have some issue because some data has been sent and some data has been not sent. So I prefer to wait receiving all data to performing database operation. And because it's mandatory, you have to return a data, empty data. It's mandatory in case of client streaming. You expect or not a response from the server. In the case of server streaming, you never return any data at the end. There is no message, not even empty, when it's streaming from the server, because you send already data in write async method. So it's a bit different for each type. This is a unary call here. I decide to return an empty response because once it's updated, I return nothing. It's okay. I just need to read the gRPC status. And in the case of bidirectional, you have at the same time async streaming reader, incoming request message, and server stream writer in case of writing. So request stream is client from the server once again, and iServer stream writer is made for sending data from the server to the client. So I can decide or not to wait for all data coming from the client. Then once I get all data from the client, I perform my database actions, and then I decide to send streaming responses. You can mix, you can send responses at the same time you get data. It's up to you. But on my end, it's more, for me, it's more clear in the implementation. I prefer receiving all data first, performing operation, and respond with streaming data. You can mix, it's up to you. Because it's a bidirectional and doesn't expect a message at the end, like a server call, server streaming call, you don't need any empty message. You complete the task. That's it. How does it work client side? Let's go to the client. I'm restarting in the meantime my microphone. So it's a console app, but I'm using injection dependency. So I am using a logger factory, etc., etc. No, sorry, I'm not using injection dependency here. It's very simple. So I create a channel with many options. So it's a bit more complicated than I show you before. When you create a channel, that open a connection to the server, you can add a logger factory, which allows automatic logging from the client. You can pass a compression provider, so you can compress data. So if you remember well, compression on binary data is the most efficient thing to do, because compressing binary data is very efficient than compressing JSON. I don't know why, but it's very, very efficient. You can parameterize message size. So it's like WCF. If a message exceeds a certain size, for example, 6 megabit, you will receive a gRPC exception. It's for, we can say, to optimize network performance. You don't want a message that exceeds a certain amount of data. So it could be a problem for the network. So this is the max receive message size, but you can parameterize the max send message size, which is work the same. I won't talk about sockets handler. I will show you a demo later, not in this session, but it's a way to ping the server regularly to keep the connection alive. If you're not using a channel, if you're not performing any request to the server, for performance, you may need to want to keep the connection from the channel alive by sending pings. If you send pings, hey, I'm still here, the connection, HTTP to connection won't close. So it could be very useful in terms of performance. How does a client, a server streaming work? You create a server streaming call, which is async server streaming call type, by calling getAll with an empty message. It's not a call, it's an object which contain all method to perform response reading. The call is not made like this. It just, the request is made, but you don't have any answer at this point. What you need to get answer, so stream responses, you need to call responsive read all async data. And in a loop, you can receive data. This is a server streaming. I will launch the app just after. In case of unary call, in one line, you will get a response, but as well, you can defer the data reading. So you initiate the call and you can read the data later. And when you want to read the data, you need to make a response async. If you want to get the data as is, what you need to do is like this. Country, and you just need to await on it. My country. So there are two syntax here. You initiate the call and you read the response later, or you can get the response ASAP. And once you get the data, you can log it. Let's go to the create method. It's a bi-directional streaming. So, for example, I want to push data from the server. What I need to do, I decide to send all data first So in case of bidirectional streaming, I send all data to the server with request stream write async, and I can say to the server, I can tell it, hey, I'm done. You don't need to wait for any data from me. And then, if you want, you can read data. So it's very important here because it's a gain of performance. You stop the client streaming, but you can read data from the server anyway. So you can do it all the time, anytime. And you read the response with the response stream, read or async. Simple. And client streaming. So you instantiate async client streaming call with the delete method, and you send in a loop to the server with request stream async data. You can tell the server, hey, I'm done, and then you can read the response. So it's very different from bidirectional. You can read response anytime, okay, no problem. But in case of server streaming, if you don't tell the server I'm done with client streaming, you cannot read the response. I'm expecting an empty message, but it could have been a data that say, for example, I'm all done with a boolean true set to true. So bidirectional, there is no message expected at the end, but in a server streaming, client streaming, you can expect a response, a message, and it's mandatory to tell the server, I don't need to send you anything. So each type of gRPC service work differently, very differently. For your information, at any time you can read. Anytime you can read headers, HTTP headers. But if you want to get trailers, if you remember well, they are sent at the end. You need to wait for the response first, which itself need to be done after request stream is complete. So headers, or anytime you can get them. Trailers once the query is done. Don't forget that. Okay, let's execute it. The server is now running, and now let's start the client. I'm restarting my microphone at the same time. Here we are. So if we go to the login, we log everything. So starting call gRPC, it's the first method, getAll, which is server streaming. And we get data, we get empty. Here, country reply contains Canada. Canada has this 32,000 lakes. So I'm receiving responsive in streaming from the server. Mexico is crossed by Sierra Madre Oriental, for example, etc., etc. Now, if I want to get data from a unary call. You get it, you get the log, it's called unary, and here is the generated URL. So it's localhost. Remember, this is the name, the package name, the gRPC service name, and the method. So everything is auto-computed, like I said, and you get data. You get here serialized because I'm using compressions, so this is normal. Create, which is a duplex streaming. So in the log for bi-directional streaming, you'll see duplex streaming, etc., etc. We got a lot of. You can for sure disable tracing. You can only have debug. You can have information, etc., etc. Up to you to parameterize your logging. And at the end, delete method, which is a client streaming, and we have logs and the URL and everything. Country with ID1 set for deletion. Country 2 with ID2 set for deletion, etc., etc. You even have an information when you get response errors. All country has been deleted. I log this message once my server streaming is done. That's it for today. So I will get more in detail for the compression in another session. I will show you what are interceptors, which are middleware for client, but also for the server. Interceptor, exception handling, etc., etc. Yeah, compression server side as well. There are many things. Even GWT authentication, I will present it in another session. So only one thing, it's a gRPC Web Demo. So everything I'm saying here, you can find it in my blog, okay? And if you want to have a demo of gRPC Web, as you can see, there is the same piece of code. Up. You can check how it works. Yeah, I need to. Here, get whole method, and I get text. And with gRPC Web, when the call succeeds, the status is in the body response. When it fails, you get the status in trailers. Important to understand. So that's it for me. What I can show you now is my references here. So here are all web references I used to make my demo. I will send my PowerPoint to organizers. I will remove some contents because some contents like the back. I just wanted to say I will provide you all references, okay? So I will give you the PowerPoint, but please don't take screen capture of this image. They are part of my book, and my book is not released yet. So please don't use them. I will anyway remove them from the PowerPoint, unfortunately. I cannot show you them. The rest, you will be able to get it, except my images like this. That's it for me. I'm done, and thank you. And sorry for technical issues with my microphone.
That's completely fine. So, guys, you are watching us. Do you have any questions? We just need to wait a few seconds because in YouTube they are watching the past. It's not truly alive. I think it's fine then. Do you have anything more to say, Andrew? Anthony, I'm sorry.
Yeah. I can answer any question if people want to reach me. Else, thank you for attending all, and thank you to you for your invitation.
You are very welcome. And just a few comments about the presentation. Besides the microphone problem, I enjoyed very much your presentation. You talk so much. It's good to hear you talking about this topic, as you are really a specialist about it. And please come back to talk to us about other subjects or even a deeper experience in this. And when you launch your book, come to talk about us.
Sure. We can plan in 1 or 2 months a new session, more in deep dive, because I could not talk about everything. But yeah, I cannot talk about everything in only one session. Maybe 2, maybe 3. But I'm available for a next session. No problem.
Okay. It's like you have a new series here in Developers Bay, leading by you.
Thank you.
So, guys, thank you very much. I think you all liked this content. We plan to bring it more and more, just to keep you guys advised. Thank you, Anthony, to come talk with us. Thank you, everyone. I think this is it.
Thank you. Bye, Brazil.
Bye, everyone.